You could maybe Slavka, maybe you want to stand next to me for now, because Viran then will continue. So it will take like first I'm talking, then Slavka will add some words, then Tobias has a presentation. It's already on, right? And only then.
Let's just double check. I didn't get the confirmation. Can you see the screen?
Yes, we do. Ah, they already hear us. See us. Audience. Cool. The presentation. Do we see the slides? Just give us a couple of minutes. Yeah. Okay. We are online. Yes, thanks. Let's switch on the music because another party goes on, right? Hello, everyone. Hello, the back seats. Hello. We have some seats on the front side, so we are not biting, as I usually say. Have a seat. It's going to be a really interesting evening today. Thanks, all of you, for coming. Together with Daniela, who is on the corner there, and Evgenia and Slavka, we are hosting this amazing meetup today. And Willkommen. Celus is collaborating with us, and Slavka is representing Celus today, and other amazing people who are wearing this white T-shirt with the logo Celus, obviously. So, and on behalf of IT agency called Tech5OG, we are collaborating with Celus to host this event and to have all the speakers with today, Maxim and Viran, yes. So now you definitely remember his name because I forgot it, and no one is allowed to forget it today. I'm Uliana, helping today Pi Munich. It's been a long time since I've been here. I'm running my own meetup related to frontend, but I'm happy to be back. Today, we're gonna have a couple of rules about the venue, and Slavka will introduce those rules. Also, we're gonna have the setup a little bit different from what you get used to. We're gonna have one first talk with Viran, and then we're gonna move on immediately without Q&A to Maxim with his talk. Then you prepare your Q&As, just keep it in your mind or write it down somewhere on your iPhone, Android device, any other device you have, and on the paper also works fine. Then we start the Q&A. It will last 15-20 minutes. I will hand over this microphone so that not only you hear me and see you, but also we do the YouTube broadcasting so that they hear you. So don't be surprised with this weird thing here. This is how we ensure that everyone hears us. Not only those who are on site, but also those who are online, right? You don't need to click here anything, just keep the microphone and speak it loud and slowly as soon as you have a question. After that, there's some time slot for the panel discussions if we have. If not, then we close the event with official part and we move on to the networking. This is the time when we're gonna have the catering, the food, kindly offered and sponsored by Celus. Thanks for that. We already have some drinks here, but more to come. So no breaks in between. As soon as we start now, we finish only after the panel discussion so that you understand where to say and what to do next, okay? Then I hand over to Slavka. Thank you very much. The stage is yours.
Thank you, Uliana, very much for introducing us, for introducing the event. It's my pleasure to welcome you all. My name is Slavka. I'm a talent acquisition and employer branding manager at Celus. I've been with Celus for 2.5 years, roughly, and still going strong, enjoying my job. And part of my job is also organizing cool events like this one, and it makes me happy to see you all here in our office and office building. Speaking of our office, some of you might have seen that we are doing office tours. If you are interested to continue or to join them, contact my colleague Laura here. She's the organizer and she will send you 1, 2, 1, 2. 1, 2. 1, 2, 1, 2.
It should be working now.
1, 2, 1, 2. Just a second, let's try this one.
Do you hear? No.
Okay.
That's something we haven't prepared for. So
It's a little technical.
Yeah, let's wait. So let's keep the level of the noise as low as possible with respect to our presenters. We still do have the audio while broadcasting, I think, because that's this microphone. But this one probably needs some reset, and let's wait till it's back. But just, Slavka, if you could then keep the voice. And
sure. Can you all hear me? Okay, I'll be doing my best to speak a bit louder with more energy. Yay, we're back. So I should have just spoken louder since the beginning. Where was I? I was talking about office tours and Laura. Laura is the one, if you are interested in office tours, the second part of office tours will be after food, because we are all excited to have food first, right? So feel free to find her and she will take you up. Couple of other information. You might have noticed that on your left, there is a lot of drinks. Also, feel free, some beers, some lemonades or water. There is more drinks in the catering area. Speaking of catering area, you will find it as soon as you get out of this room to your left. So food will be served there, as Uliana mentioned, from 7:40. And another important information, in case you are a smoker, please note that the entrance door that you came through is going to be closed from 7 p.m. So you will not be able to get in. Therefore, if you are interested to smoke, you can use the glass door here, but please close it right after, as you see that it's open, because our cooling system will not work otherwise. Let me see what other information I have for you. One last very important information is that my lovely colleagues, Irina and Jue, are taking pictures and videos. We want to have memories from this event. And in case you do not feel comfortable being on the video or a picture, please approach them directly, notify them, and they will make sure that you are not on any of the videos. Other than that, I would like to say that me and the entire Celus team in white t-shirts or t-shirts saying Celus are very happy to see you here. We have plenty of open positions, so you can talk to all of us about it and have fun tonight. I will give word now to our CEO, Toby. Round of applause, please.
Thank you, Slavka. You see, I'm already the first guy breaking the rule in the black t-shirt. I'm super excited to have you all here, and to also, before we dive into the really interesting topics, tell you a bit about Celus and what we are doing. If you think about electronics in an overall context, you'll probably have all kinds of devices in mind, from phones to computers to coffee machine, a thermostat, all of that. And for a lot of those devices, we're talking cutting edge stuff. Really complex engineering, really complex devices that come out of that. So you may think that that must mean that the process behind designing those is as advanced and as cutting edge. Unfortunately, I have to tell you, it really isn't. That is that shown? Okay. What you will see in a second is pictures that I actually took in my, before I founded Celus in my previous role. Exactly. So real life job in electronics engineering that looks a lot less cutting edge, I have to say. Typically EDA tools in the electronics world that are used for designing are still pretty much based on software that was developed in the 90s and latest from the early 2000s on barely changed. Engineers have to manually work through a lot of components. And to make that even worse, it's incredibly complex. That is just one part of a design that illustrates that a bit, but it even goes beyond that. There are currently about 600 million electronics components out there for an engineer to choose. Let that sink in. Every component out there has a data sheet that is between 100 and a couple thousand pages long. So you're talking billions of pages that an engineer would need to know about to make the best possible design choice. That by itself is simply impossible. No one can remotely get close to making the best decision. So what do engineers do? They have memory. They remember designs that they did in the past. They repeat what they've done before. They ask colleagues. They use Google to search for components that show up on top. So they are okay with not finding an optimum to simply make that amount of data perceivable. But now, for probably a lot of us, we didn't go into study electronics engineering or any technical field to become datasheet reading monkeys that comparing voltage levels and tables. No one is here for that. We're here for solving problems, for finding a new solution to a challenging situation. And that is what we at Celus are driving at. We want an engineer to have all the information available to them, make the right choices in the fastest possible way. And to build that, we actually found a second party in that overall process that has an even bigger problem than the electronics engineer. And that's the component manufacturers. Think of all big semiconductor companies out there. Think of a Texas Instruments, a Infineon, an Intel. They want their components to be found by engineers. They need engineers to be able to use their components to be able to build a design out of them. The current solution for them is they make all of those lovely data sheets, and also for their top customers. So typically you're talking about ballpark the top 10%, top 20% of their customers. They have account managers, support engineers that will help you figure it out. If you're an engineer at Apple, probably people will help you. But for the 80%, the 90% of engineers out there, you don't have that option. If you can try building a design and call up Texas Instruments, probably no one will even pick up the phone. And that is a big problem for them because that is still the biggest chunk of their revenue that is completely unknown to them. And to just show how big that overall gets is component manufacturers create over $1.4 trillion in annual revenue from those components. And over 50% of that are from customers that they never talk to, that they probably don't even know the name, simply because it's that long tail heavy. There are so many small companies out there that make up the majority of the industry. We slide in right in between. We take an engineer by the hand, ask them questions, let them describe the functionality and the project that they want to build, let them basically fully give us all their requirements and functionality. And we, like a trusted advisor, as we like to say, guide them through the flow, recommend designs, and at the end of the day, export a full bill of material and a complete schematics design. Because unfortunately, building smart component search engines is not enough. To be able to find what component fits, you need to do the actual engineering behind it. And that is what made us turn into a full design automation company, where we have to cover the entire process from your idea to a complete schematic file, which we then output into the existing formats that engineers already know, where we make sure it looks and feels like done by a human engineer. And that, now I'm probably telling something pretty obvious to most of you, that industry is insanely huge. Companies currently spend about 6 billion hours designing electronics. That, just for some scale, is 6 times as long as the time elapsed since human first existed. That is spent per year on looking through data sheets, drawing schematics, and building layouts. That is an insane amount of effort that we as a society put into building those designs. So every % you can save off that is a really big deal. And even purely financially, the simple market size of electronics and electronics components is insanely huge and applies to pretty much all industries. You probably cannot make it through an hour of your day without interacting with any kind of electronics. A little bit more about us before we get to the really interesting part of the day, and I hand over to Viran. We are founded in 2018. As you can see, it took us quite some time to pull this off. A lot of engineering went into making that platform work. We are headquartered here in Munich. We, in the meantime, also have a design center in Porto in Portugal, and have commercial offices in the US with a commercial headquarters in Austin, Texas. We're currently already more than 90 people. It's hard to keep the slides up to date, and have about 30 million euros in total funding so far. And keeping the hard to keep the slide up to date is already the perfect lead over to that slide. We are constantly growing. We are roughly doubling the team every year. We're very much growing, very much expanding. So we have a lot of open positions that all of my colleagues would probably love to talk to you about. Here are just some of them listed that probably are most interesting to you guys. Reach out to us. We would love to talk. Thank you.
So now we are switching to our first speaker, Viran, and he is a software engineer at Celus, and he's going to present and talk about creating domain-specific languages with Python. Stage is yours, Viran.
All right, thank you so much. And thank you all for coming. It's real nice to see all these faces interested in the topic. So today I would like to talk to you about domain-specific languages and more specifically what it takes to create one in Python. Before we jump into that, briefly about myself. My name is Viran Ribić. I am a software engineer here at Celus, where I mostly work with the backend APIs with Python and also on our search engine, which is written in C++. But domain-specific languages, okay. What are they? Why would you even care? It's kind of in the name. A domain-specific language is a language built for a specific domain. You can use them to solve problems that would take too much code and effort to think them through in general-purpose languages. To give you some examples, this slide here hosts a bunch of different tools an engineer could use to solve their problems. I would give you a second to read through them. Maybe you can recognize some as general-purpose, opposing to others that may be domain-specific languages. And I would like to do another thing. So who would be interested? You can take those phones out and scan the QR code. And I'd like to see if you could recognize some of the DSLs that we see before, or maybe some that you know, and put them on the presentation here. So I think it's going to be a nice small moment for interaction.
There will be a present.
There might be a present, might not, might be, might not. Don't miss out the opportunity though. And let's see. Okay. Lua, there you go. Okay. Anybody else? R, interesting. Interesting. Whoa, nice. Puppet, Docker, nice. Mongo, Django, Docker files. Okay, okay, okay. This list is growing. Awesome. 32 responses, 34. Nice. Okay, so I'm going to stop it here. But guys, you're really spot on here. Some of the examples that you could see are basically HTML, as people identified, Docker files, for sure. Now, there is some gray area. Bash, some people would say it's a general-purpose language. You can do a lot in a Bash. At the same time, others would disagree. And R there, although being fully functional Turing complete language, it is mostly used for statistical analysis. So there is some gray areas there, but overall, like VHDL, HTMLs, LaTeX are all domain-specific languages. What got me interested into the whole topic of domain-specific languages, well, you can see here, hopefully you can see, are two different texts. They're kind of gray, they're kind of hard to read, and they are part of my notes. Over years of engineering, I was putting them aside and trying to collect my own knowledge base of all the different topics I was covering. And this thing grew and grew. It was at some point really hard to crawl it, hard to find information. And I was also wondering, okay, how do these fields relate? Ideally, I would have a tool that would help me find all the overlaps between different nodes so that if I have some kind of repetition between different domains or languages, the tool could highlight that to me and basically give me back that result. Ideally, such a tool could also be used for some visualizations and maybe artistic renderings, because it's much easier to find information. Well, maybe not in this picture right now, but when there's a nice visual representation of what you're searching for. So if I could have a tool that could connect different nodes that I made and find different keywords for specific domains, highlighting me what are the relationship between those, I could basically navigate my nodes more easily and find my way around them. So this is something that we would like to be building today. Ideally, there is a tool that we have that takes all of our nodes, enables us to organize that in a graph, and finds all the relationships between different nodes so that we can understand better our knowledge base as we build it over time. So, how do we approach solving this problem? On the one hand, you could think, okay, there is a rendering I want to create. Let me start with HTML and CSS. Fine, that could be done. But that thing requires a lot of code. A lot of code to generate such a graph is suboptimal, at least in my opinion, because I would like to have something that's a bit more elegant, a bit more easier to use, because I would also like to iterate faster on these solutions that I'm searching for. Next option would be maybe using a dedicated tool like Mermaid. Again, at this point, you're looking at something way more simpler to use. There is some definition that goes into the theme of the solution, but at the same time, the syntax is quite clear. So if I want to connect two nodes, that's easily convertible into a graph. But my original problem was a bit different. I wanted to understand what are all the different keywords that are connecting two nodes. At this point, I manually need to define them and go one by one to create such a rendering. That's, again, something not really the solution for my use case. What I wanted to see is I wanted to have one definition of my problem, one node containing some kind of text, with another node containing another piece of text. And if I say that I'm curious about the relationship between them, I would just define such a syntax. At this point, the tool would automatically generate the original graph from the beginning, and I could get my results more easily. You could say at this point, well, that's just Python, that's just JavaScript. You could use different tools that already exist to solve this problem with maybe a bit less hassle. But for me, this was also an exercise to try to understand how compilers work. And I was really, with my mind set on building such a domain-specific language. So what I decided to do is as follows. On the left side, you can see the syntax of the language that we want to have. On the right, there's the first iteration of rendering of how would that solution look like. You have nodes that render into graphical objects, and you have blocks of the configuration assigned to specific nodes that could change some of the properties. Finally, the last line is the connection, where we connect two different nodes by a line, and that way we can build our graphs. Our problem basically consists of that. From text, we're going to a PNG, an image, an output of our compilation. And that could be done in many different ways. We could try mapping different characters onto pixels, but that feels a bit wrong. You would ideally want to have some kind of intermediate layer where you could control how this rendering is done, maybe even provide different outputs. So there, we would introduce an intermediary model, calling it a JSON here, that will enable us to split this process of compiling from our input into our output. It's important to know that when it comes to the compilation from your input program into the model, that would be called the front end of your programming language. While when you go from the model into the output code or image, that would be called the backend. So I'm going to do a simplification here. There is a tool I'm going to use to solve this backend problem for me, and that's NetworkX. So the plan would be that from model into the image, I'm going to bootstrap from a different tool, a graph processing library that is popular in the Python community. At this point, the problem becomes going from the input text file into the NetworkX model. Basically, that's on low level what we want to achieve next. We're going from our text into the graph syntax of NetworkX. How are we going to achieve that? Well, the input of the program is just a string of characters. It's a text. Therefore, we would treat that as an input and analyze it element by element. First things first, we can remove the white spaces. That leaves us with just the symbols that are relevant for the syntax of the program. Then we're going to color the specific characters into the types to which they contribute, the groups they belong to. You can see here that node is an identifier. The block in the middle containing the key value pairs is going to be an object definition. And finally, the arrow will create a different kind of mapping for that part of the syntax. We're going to skip the middle one, just for the interest of time. And we were going to have a look at different elements that are created through this process. So node here is a set of characters that get back to the identifier, while the end of line marked by this character is a separate token in its own. Tokens are these names of the groups that we would use when we build the first level of the processing, which is the lexical analysis. Following that, these tokens themselves form sequences, and whenever we see identifier followed by an end of line, we're going to treat that as a node. Nodes are one of the basic building blocks of our language, but just to drive this point home, let's repeat the whole process, this time with a different sequence. We're looking at the identifier, followed by an arrow sign, followed by another identifier, and an end-of-line character. This thing is going to be mapped into an edge, which again forms the input of our program. Initially, we saw the identifier followed by an end-of-line, identifier with an object and another end-of-line, and the arrow syntax that happened on the input. All of these sequences are part of a root node, which again forms the root of what? Of a tree. This tree is a common data structure used in compilation languages, in compilers, and it's called a parse tree. So if we would to roll back the whole process, we would see that the root node contains children nodes, 2 nodes and an edge. They themselves have the intermediary tokens, which finally map to individual characters. With this process, the parse tree is complete, and we can start exploring the intermediate code generation part. But just to wrap up this sequence, what we see on this slide is something called a grammar. The grammar is used to define the core of your language. It is how the syntax evolves and in what format you can write your programs in order to describe your problems. So for the code generation part, we can see that the nodes have their own functions. Every node, every type of this solution will map into a specific syntax that would build our graph. Whenever we detected an object, we're going to assign that to the node, while to identifiers followed by an arrow, we're going to create an edge of that network X graph. If you jump to the demo next, we could give me a second for everything to get going. But I would like to highlight the 2 major packages that were used for this demo, the parsimonious from Eric Rose. A big shout out to the gentleman. I think this package was really fun to work with for this and other projects I had. And if you proceed to the core of the program, basically the grammar that we just saw and analyzed is the input to the programming tool that would enable us to create the parser for our custom language. Another important part is the node visitor. This element here is going to go through every of the tokens that we identified in our language and enable us to create Python object equivalents that we will then use to put up together our final rendering. So if I just jump over this part here, we can come to the final output. The initial definition of the problem was as follows. We had a node with another object-defined node and an edge between the B and the C nodes. And the rendering that would come out of that is as follows. If we wanted to come and go back to our original problem, there the individual nodes would be defined with their own text properties. These properties would be the nodes that we wanted to analyze, and upon rendering them, we could achieve the original goal of finding the relationships between them in our knowledge base. All right, so now going back to the slides and a brief wrap up, whenever you write your own compilers, your own domain-specific languages, you need to take into consideration the following steps and some design choices that will come through them. The first thing you need to take into consideration is the lexical analysis. Their individual tokens will be bundled into, individual characters will be bundled into tokens. The syntax analysis following the grammar are going to use these tokens to create intermediary nodes in the parse tree and create that structure. Semantic analysis, which we omitted here, is used to check specific rules of your language that might not be easily implementable in the previous steps. Think of a variable definition. If a variables need to be defined before use, that checks would be done in the semantic analysis. Finally, intermediate code generation is something we use to create our intermediate model. That was the network graph. In other programming languages, say C++, which is compiled, this intermediate code generation would be an intermediate step, a custom language, not really assembly, but also not the original input code that can be further optimized before it's used for code generation. To sum up the whole topic, languages are split into general purpose and domain specific. For the domain specific languages, you would further create a divide into internal and external programming languages. Internal programming languages are languages that use elements of your programming language to define the syntax of your domain specific language. Think Ruby on Rails, or maybe on macro systems of some programming languages like C++ or Rust. For the external programming languages, which is what we did, you need some kind of a grammar that describes the language, and then you have to make another choice. Will that language be interpreted, or will it be code generated? For the interpreted languages, it means that they're running on some kind of an underlying engine, while the code generated ones are targeted towards binary code and executed directly on the machine. Our case was the interpreted language because we built upon Python and Network X to make it happen. Some ideas for future improvements. If anybody of you wants to play around with this code, you could extend the syntax of the frontend by defining different operators. You could also extend the backend of the language, maybe turning the renderings into a Blender or another tool, maybe also extending the algorithms that could be performed on these graphs. Or finally, even code generation. Now that you have the intermediary nodes, you could have a look at, well, how could they generate Python abstract syntax trees, something we would learn more in our next panel. But if that was not enough for you, and we want to play around with some visual DSLs, Celus platform would fall in that category. The idea behind Celus is that we take some high-level description of your problem, defined as a graph, and compile it into the output files. So both the schematics and all the other output files needed for electrical engineering are created by the Celus platform through such an intuitive interface. Pardon? If you're curious, you can scan the QR code and learn more about the platform itself. As for the positions, I think you already heard that, but you're hiring, and there are some of the Python-related roles you could apply for following this QR code on the slides. That's it. So before we proceed and wrap up, instead of having a Q&A session, I planned a reverse Q&A session where you're not going to be asking the questions, but I will be asking the questions, and you will be answering them. So if you would please scan this QR code, we would have a small quiz. And for this opportunity, maybe there's a prize behind it, maybe there isn't. So whoever wants to join, you could consider joining. Wow, okay, people are joining. Let's gonna give it some time. Okay.
Wow.
By the way, I have to say, in case there is a prize, maybe, it won't really go over the internet. So even though everyone is free to participate, the prize might be only given to the people in this room. Okay. Maybe. Okay, I think at this point, we're roughly, okay, still growing. I don't want to cut this short quickly,
Let's
but
make it 80, come on, 80.
Let's reach 80.
2 more.
Two more. Come on, guys. I know you're there. I know you're listening. Okay. Okay. Not 80 today. Then let's proceed with 77. So the first question is coming right up. And it's going to be a simple one for the start. Identify a general purpose language. You have some options there. Let's see what's going to happen. Okay, 56. I don't know. But maybe I should have said the fastest finger will get the most points. So there is a scoring strategy that would enable you to find the first place. And nice. Okay, well, JavaScript, good. You guys are paying attention. Now, let's turn it around and ask the next question. Will we? Oops. Come on, work with me. Okay, I guess I need to do that every time. Now, the task is to identify a domain-specific language. Nice. This time everyone has voted. Okay. I guess this one was easy for you. Okay, this room is full of professionals, I see. Okay, good. Let's try then. All right, I didn't show the leaderboard. So what's happening here? Chris, Mr. Chris is really good at this one. All right, okay. Let's see if we can break the tie there. 77 of us, 78, let's roll. What is the first analysis step during compilation? I'm sure you guys will know this one as well. I have a feeling. 72, 74. All right. Couple of more seconds. And the first, okay. Good. Well done. Nice. Let's see what's the status there. Okay. And Hayes now in the lead. This is quite competitive, all right, for 70 people, almost 80. There's a lot of engagement. Okay, guys, final one. Let's try this final one, okay? 78 of you ready? And okay, and now this is a bummer. I think this is on me. Oh, it's okay. It's rendering. So what is a subtype of external DSL? Pardon, I guess this slide got broken. So what is a subtype of an external DSL? By the end of it, we saw some external DSLs, and the options are general purpose, interpreted, intermediate, and recursive. Okay, you guys cannot be fooled. Awesome. So with that, let's see what's the final decision there. Oh. Was there? I guess we have a winner. Mr. German, I have to say the prize for you is the knowledge gained on this meetup. So well done. Besides that, I'm joking. There's also this beautiful book I can really recommend. I use it often as a reference. It's called Domain-Specific Languages, Efficient Modeling, Automation, and Reuse. So hopefully, please take the screenshot and don't lose your session. Otherwise, I would not be able to find you. And you won this prize. So, and thank you for taking part in that. Thank you for listening. Hope you had some fun, learned something new. And that's it from me.
Applause to Viran.
Thank you.
So thanks a lot, Viran, for all the quiz and fun and a lot of learnings. Maxim is our next speaker, and we will play Code Detective, uncovering complexity with Python's importlib and AST. So I hope you have seen the description from Maxim. He wrote it and shared it at our page. And yeah, a couple of things we haven't mentioned. We need to leave the venue by 9 latest, just in case. And what else? Again, if you need to have a break or something like this, just do it right here because the door is already locked. And if you struggle to find the spot where to put the bottles, just put it somewhere next to this place where you took it, and not just spreading it everywhere, you know, then we might break it and have some glasses around. That's not what we want. Okay, Maxim, are you ready?
I'm ready.
Yeah, but the microphone isn't. So
I'm ready. 1, 2, 3, 4.
take mine. Then Maxim.
1, 2, 3, 4.
Welcome,
Thank you.
Maxim, on stage.
I already share it. Yeah. Bildschirm präsentieren. Okay, we can see it, right? Hello, everybody. My name is Maxim, and today I will speak about abstract syntax trees and how they can help us to find a mess in our projects. I hope it helps. And before I start, I want to say thank you for my family who supported me on every my presentation, and thank you for my wife Elena, for my children Mark and Maya, and thank you for our animals Marcel and Kisa. And I want to say thank you also for my daughter Maya, who created illustration for whole presentation in this year. And this is a Python. Thank you, Maya. And we also, before start with my topic, my name is Maxim Danilov. I work more than 25 years with software development, and I work extensively with JavaScript frameworks, and also I provide mentoring for newbies in Python more than 10 years. And links to slides and to code which I show on the next slides, you can achieve by this QR code, and you can find the QR code later on the presentation. Okay, abstract syntax trees, what is it? This is built-in module in Python, and abstract syntax IST module provides us two important interfaces, parse and compile. With parse, we can transform any text in one tree, which contains, every node in tree contains Python objects, which present one element of Python syntaxes. And with compile, we can convert this abstract syntax tree back in text, which can be later transformed in Python code. And also we can visualize a syntax tree. With last update in Python, we can visualize syntax tree directly in module. IST dump, this allows us, but also we can visualize syntax tree like a graph, because we have graph views. I create for you some script. You can give any Python file and transform or visualize any Python file in graphs accordingly to how to IST parse our text in nodes. And below you can see example of Draft Graph PI. And our detective tool, IST parse. IST parse transform any text in a node which contains element of syntaxes of Python. Important suggestions. Of course, we awaiting this text contains some Python code. The result AST describes part of text itself, not describe not the Python code, and it means one node can contain import. Import is nothing. This is not only word with additional arguments, and important is with AST we can work with dangerous code, because any computations nothing happens with computations. Computations are omitted, and also any types not converted. If I write one, it's after parse transforms to char one and not the float or integer. And if parsing happens without any exception, the text can be imported through import lib, or exec can apply it. The code is correct. Okay, and let's see how I can visualize a small part of code. You can see above we have some imports, and on visualized graphs. After that, we have some function, and after that, we have some calls. Don't matter how it seems. Important is we have imports, we have assigns or something else. We have definition on or function or classes. And into these definitions, we can have bounded expressions. Something is computed, and also we can have unbounded expressions. It thinks something happens directly in Python code, in module, and the first problematic place, unbounded expressions. Sorry, I create the small script, check expressions. For this script, I give the folder with my project. The script goes through whole project, for example, 300,000 lines, and back he give me a list of expressions, unbounded expressions, which happens in module. And why I think this is a big problem or big mess? Why? Because, for example, in one file we have standard structure we call logger, and we set level. It's okay. For next file, it's also we call logger, standard root logger, and we set level. And gotcha. In some file, somebody from my developers write, instead of info, he write warning. But problem is, we don't know in which order these files is imported. And in this case, we cannot predict on start which level will be set. And this is a big problem. Exactly this problem, this example, I found in preparation of my project, of my presentation, and this project is already 9 years old. It is around 400,000 lines. It's 3,000 files, and I found this error. I don't know why nobody find it, but unbounded expressions is a problem. They provide hidden change of project state. They create unpredictable side effects, and they have unpredictable moment of evaluation. This is a problem. You cannot hear me? Unbounded expressions written directly in your file on the 0 level. It means if you import this file, these expressions already computed or evaluated. If you put this expression in one file, this is in one function, this already binded with function call. Okay, guilty. Unbounded expressions, it's really a huge mess in our projects. Believe me. The next suspect, imports. What's the problem with imports? Everybody use it. But let's try check a correct usage of imports. For example, this is visualization from one my project. I also write small utility which check all imports and provide us free reports. The first reports, how many imports I do per file. The next report, how many classes I import in every file. And last report, how many classes I import in one import line. And you can see example, and in this example, you can see the problem with IST module. If you use HTML tags in docstrings, IST module works with errors. And that's why I offer you not to use HTML elements in docstrings. But okay, how it works? I go simply through whole lines of every file, and simply I sort and collect only import nodes from IST3. And what happens? For example, I get a result. In one file, I have 129 lines of import. What happens with my developer who created this file if he should import too many lines, if have too many lines of import? Okay, in tests, I understand it. But for example, this service factory is perfect example from Javaton code. Service factory, this is a simple example how Java developer learn Python and create programs on Python. And this is only the signal. Probably there I can find a God object with high coupling with other elements. And of course, this is concentration of complexity. Next report, count of classes. In one file, I should import 75 classes. Me, like a developer, I can operate with 5 till 7 elements. How genius should I be to work with 74 elements in a file? Or probably I have some problem with architecture why I need to import it. Okay, but important mess there. Probably we break a modular design. I answer about it later. Okay, and at last, how many classes I import in one line? For example, on get monitored observation file, I have on line number 17, 43. I import 43 classes. Don't matter, I have black or not. This is not readable, not workable. This is a mess. And thank you, IST. He can help me to find this. Not every linter can help me with to check it. And of course, this is a cognitive overcomplication. But breaking of model design, what I mean? For example, in Django, on the left side, the Django developers means I import only models module, and after that, I use models module like it's written on the left side. I simply use charfield, foraging key, or something else like an attribute from models module. But in standard project, the developers don't care completely about what creator of library think, and they start to import directly every element from library. And in this case, In this case, probably in code, it seems a little bit better, but with imports, it seems really, really huge and not usable. But here is opinion is subjective. I like right now, I like the left side of code. Okay, but over engineering of imports is it's a big mess, and as symptom, you have a God object in imports in file. Probably is a violation of modular design. This is concentration of complexity if you have too much imports, and cognitive overcomplication. Next aspect, coupling and cohesion. Lieblings word for every developer who don't want to write a code. And coupling and cohesion. Correct usage is this, but I write for you some special script, perform extraction, and this script simply copy one file with all dependencies in other folder. And you can see how high coupled this file with any other modules in your project. And you can see in project with 2000 files, I have only for one endpoint, I should copy 500 files. It means this file is coupled with one quarter of whole project. If we, how it works, I use IST, I go to the first file, I find import, and from import I copy, I find the relation to other file, and I copy it, and repeat it recursively. Result. In source, we have 2,700 files, 700 folders, 21 app, and only for one entry point, I need to have 11 apps and 750 files. In this case, it's too high couplet and a file with any other files. Huge coupling. Please don't do like this. Don't do like me. Okay, and let's go deeper on last my element in presentation. Type hints. I find in previous results what I have some imports only to use it in type hints. And I have decided what happens if I remove type hints. What happens? I use IST. IST give me information about any hints there it's written, and I can remove type hints and change to types any. And result of this script, everywhere you can find now typing any. And right now you have unused imports. And after that, I can use autoflake to remove unused imports. And what happens? I run IST extractor, I run autoflake, I run IST extractor again, and results. For this same file, previously, it was find 560 dependencies, and like a result, it was 787 files find it. Without type hints, the same project, dependencies only for one file, I have 731 file. It's around, in compressed form, it's around 15% lower. And in this case, this is my last sentence. I only want to show you statistically type hints improve coupling of your projects and increase complexity in your project. I'm not against type hints, but my opinion, probably we use type hints wrong. Sorry. Thank you for your attention. Code and slides you can find by QR code, and I'm open for question. Thank you.
So we're gonna have a quick setup and bring a couple of chairs so that panelists could sit comfortably. And Viran, maybe would be cool to have you on stage as well. Let's set up the camera so that people who join us, we have roughly 25 people online as well. Thanks for joining everyone online. That's the power of hybrid events. I'm not sitting, I'm actually the one who is running around and giving you the microphone to ask the questions. Who wants to be the first? Raise your hand.
Hello. Yeah, so this is about the first presentation. Thank you so much. The question is, if you wanted to implement linter support for the custom language, the DSL that you developed, how would you go about doing that?
Well, that's a really good question. Well, first things first, it's still an experimental language, right? Therefore, the syntax is evolving. It's mostly about a prototyping language, right? I guess you saw the logic of connecting the nodes with all the different keywords. Well, first things first, if you have the parse tree, you could prepare different pattern matchers over it, and you can analyze those for specific things you want to identify. On top of those patterns, you could then make decisions like, do I want to raise warnings or errors, or do I want to maybe implement an automatic formatter that would then structure your syntax according to that. Now, it depends on what you want to do there. I have to say I don't have that answer. I didn't have a clear expectation of the syntax. I want still to have it evolving. So I guess that would be my answer there.
For linter, I write my own linter for my code, and I can say if my linter works with abstract syntax tree, for me is completely don't matter which syntax lays behind in text, because I works with nodes and I works with rules, how every node compares or bind it with other nodes. And for me, it's completely don't matter which language, which words is it. I think this is easy.
So are you aware of any tools that would like ease the process so that you just give to it like a grammar and it gives you a linter or like maybe an IDE integration autocomplete sort of thing? Or do you have to write it yourself from scratch?
So depending how much you want to experiment with everything, I know that JetBrains has some tools that would enable you creating your own domain-specific language from scratch. Depending how you want to get your hands dirty, you could go for, all the way from C to Python to maybe JetBrains solutions. But I don't have any details on those. Maybe you could comment. No.
Okay, thanks. Who is next? I see the hand here. Vittorio.
Hello. Just a curiosity. I want to know if the parser is. Do you use a compiler to generate the parser, or you hard code the parser?
So there is a compiler. Maybe I wasn't clear enough. The tool I was using was Parsimonious. Parsimonious is a Python package built by Eric Rose, I think a decade ago or something like that, that takes the grammar of my language, parses it through, and creates a compiler so that it's a compiler, correct.
Thank you. Who's next? Yes, I see another hand here.
My first question for Viran. Or Viran, I don't know which one's the correct version. When do you decide that it's better to start designing your own domain-specific language rather than just use simple functions or existing library?
Well, so great question. I think that is the question. My answer is depends, right? If it's for yourself, I guess you start when you're bored. And I mean, if that's how you have fun, that's how I have fun at least. You would go for a domain-specific language. But that, if you want to like dive into that question, I guess you would need to understand the repetition of code that happens and who's the user, right? So if it's the programmers, engineers, developers that are using that, it could be the case that they're all versed in a good programming language. You would not need a domain-specific language for them. But if your users are a different kind of user group, say electrical engineers, you might consider having something like VHDL, which targets their needs, the way they think about the problem, captures that in the syntax, and then enables that transfer into whatever runs on your CPU at the end of the day. So again, I don't think that's a satisfying answer. I would not be satisfied if I heard that, but it is a depends case. Would you maybe add on something to that?
Next question.
So do you have?
But I have a question for Maxim as well. You said in the last sentence of your presentation that we use imports wrong for type hinting. Can you elaborate on that? What is the correct use?
I don't have any solution what is exactly correct. I try to use many different ways to use with type hints. Probably the last solution which passed only for me, I use type hinting with doc strings, and thank you for PyCharm. They also offer us since 2021 type hinting in doc strings. For me, why is it important? I can collapse it and I can avoid to see it. Type hints in functions declaration, you cannot collapse.
Evgen, I will give you the microphone. Evgeny, I'm coming.
You mentioned that imports is not good for typing. Can you explain why? Because I have no expertise in that.
Once more time. Sometimes I see that strictly directly import from any other part of library or any other application, import one class, which I should provide like returned type of object or like type hinting for attributes for function call. And if you can of course write string form of this class, but if you write only string form of this class, the IDE don't knows about this class. You should somehow import it before in this file. And if you want to provide the full support of type hinting in your IDE, you should import somehow this class.
But why is bad to just import, for example, import list from typing and use it for hinting? Why it's bad?
No.
It's like for performance, it doesn't like. It doesn't.
Beautiful question. Sorry, I skip it in my slides. I never change type hints like a string, list, integer, all basic types.
Basic
contains.
For example, list, for example, types or whatever, label or.
All this is important. Protocols, base classes, all is normal imported. Okay. I remove only imports from classes from project.
Okay. I see. Thanks. Other questions? Because I have two more.
There is a question on Friday.
My question is for Maxim. Yeah. So first of all, I love type hints. It makes me write my code like really fast. Then secondly, how do you decide when to start writing custom solutions and not maybe use a rough, for example, and good code review practices and stuff like that? So how do you decide between that and writing your own AST? And then is this because this is a personal project, or what exactly is the use case here?
Thank you. Amazing question. And let me to be correct. Type hinting not made your project faster. Type hinting shoots you against the doom error, but they don't make your code faster.
Yeah, I said it helps me write faster.
Write faster.
Yeah.
I also cannot say because you should write the types. And after that, if you write the type, but you get only type hints, and you should also write the string with type conversion additionally. That's why it's not always faster. But don't matter. These examples which I show you, this is the different projects. One of them, this is a huge medical observation data lake, which works in different countries and have more than probably 2 million customers. And my goal in this case was to split project on modular monoliths, huge big monolith. I should split it on modular monolith, and therefore I created dependency extractor, and I have the 2 talks on different Python conferences about it, and I have seen the dependency extractor work better if I avoid type hinting. And at least this dependency extractor also helped me to reduce the volume of PyTorch, which I use dependency extractor directly before image creation for Docker, and I can reduce also images. And in this case, I avoid type hints also to reduce the volume of container. That's all. But decision works on the in production for million customers.
Okay. Thanks, Maxim. Thanks, Friday, for the question. We have the last chance to ask a question. Yeah, we know. So that would be our last question before we close the official part. And anyway, we're allowed to stay till 9, and we have some time to network. I already forgot what was the hand.
Yeah, thank you. My question is to Maxim. Thanks first for the great talk. I got the impression that you aim at measure the code quality using the scripts you presented. So the first question, is it correct? And if so, did you integrate this in a CI pipeline and look over the history of a project, whether this helps you to achieve better code quality?
Of course, please see the big my talk from PyCon Berlin. PyCon Letland it was. There I provide also the photo or pictures from production. For example, we start to reduce the volume of Docker containers, and right now it works. We can upload it in Amazon, because previously it was more than allowed volume for us. With dependency extractor, we achieve the same functionality, but and we should not pay more for Amazon. It was the first example, and the second example, it's about second example I already shows on this presentation about I find the unbounded one unbounded expression which breaks our logging. And this is a Heisenbug because it's not possible to find it directly. And yeah, it was 2 examples I can show you later on my laptop if you want. I'm answer or not?
Yes, thank you. So, thank you very much for the questions. I mean, you could sit. You could sit. I could pretend that I'm sitting as well. So, thank you very much, Celus, first of all, for hosting us, for being with us, for helping us, for presenting, for sharing what you guys doing here. Thanks, Tobias, for allowing this to be happening here and having an amazing team to support us with everything. Applause. They also have swags, which they kindly did with right there on the table, and then there is another table outside. They're super cute. I've grabbed a couple of them like this with Python and some logo of Celus. Thanks a lot, guys, for doing this. So please go ahead and grab as much as you want. Enjoy it. Then the second thank you goes to you guys that you came and today and dedicated your time for listening, for supporting the community, and please stay tuned. Oh, I see the same T-shirt of someone. Cool, Python Web. So if you want to know more about Meetup and Python Munich as well, so just subscribe, just join the Meetup, suggest it to your friends. For those who doesn't know, who are just newbies coming to Munich recently or moving to Munich from other cities, you will definitely have a notification as soon as there is another event on the schedule, on the plan. Nothing yet to announce, but stay tuned. And there is a submission form in case you already have a topic as a speaker for the next meetup. You could talk to Daniela. She's right here. She's one of the co-organizers of Pi Munich. And go ahead and just log this in so we could contact you afterwards as soon as we know the date and the host for the next meetup, okay? And if you don't know any, and not like the topic for the next meetup, you still want to be a presenter and you need some support or help with brainstorming, we're also happy to help. And with that, I also want to say thank you to Eugene, who was behind the scene making the setup, music, the broadcasting. It went so well today. Applause to you. Yes, and we are good actually with closing the official part and moving to the catering part and food and networking and asking questions about Celus, and talk to Tobias, the CEO of Celus, and Slavka also is here, and other employees. So that's your chance to get to know a little bit closer what is it to be at Celus, and what kind of people you might potentially want to work with. And there are also some nice Kununu awards they got in 2024 and 2023. So, and Viran is here and Maxim is staying with us. So everyone is staying. I unfortunately need to leave in 20 minutes, but if you need to talk to me, then you could reach out to me within the next 20 minutes as well. So thank you, and talk to you next to the food. So now I need to unwrap it all kindly and don't break anything.
You were well done, congratulations. I think give me a second, the presentation here right there.
Yeah, I had like.
Are you interested in the topic? Are you already working?
That's why I'm like, when can you come?
This, well done, and yeah, hope you like it.
I never had any like
Also music, it's a good place.
It's some music. Have it. You did that, right?
Yeah, sure, enjoy it.
I enjoyed the thing that you made it self-contained and
Scale so much.
Yes, it was a bit of a challenge. I think my